Let's go back to our exercise. Microphone is on, so you should hear now. Okay, so this was all right. So I was saying that this essentially amounts to, and this where is the, okay, amounts to computer limit. And the limit to be computed is this one, right? So we want to find out whether this limit exists or not. Okay, so, and the answer here, of course, this is clearly not something that you would like to solve with polar coordinates, because there are a lot of sines and cosine. It gets very messy. So when I started, when I tried to solve this, I went directly to try standard curves, and I was lucky. So let's see. So if we try with the curve 0t, for instance, so my claim that limit does not exist. Yes? Teaching. So my claim is that that limit does not exist. And let's see what happens at along 0t. At 0t, you have exactly that. That's constantly equal to 0, right? While if you try along x equal to y, we get that this is equal to sine of t to the power of 4 divided by 1 minus cosine of 2 times t squared. Now this is a function in one variable, which is I think easier to study. So let me call this g of t, and we want to compute. So compute limit for t that goes to 0 of g of t. Okay, so you can do this computation by means of Taylor expansion, for instance. So you do limit for t that goes to 0 of that ratio, which turns out to be t to the power of 4, and then we have a big O of t to the power of 5 if you want, actually more, but, and then we have here 1 minus, and then we have 1 minus 2t squared to the power of 2 divided by 2 plus big O of t to the power of 8. Okay. So the leading term at the numerator is t to the power of 4, of course. And then we can simplify a little bit what's down there. We get, well, what do we get? 2 times t to the 4 plus big O of t to the power of 8. And then there is a limit here for t that goes to 0. And then you can just collect a power of 4 above and below. So we get 1, and then we get a big O of t here. T to the power of 4, we get 2 plus big O of t to the power of 4. Simplify, and then you get exactly 1/2. So yeah, so along this this straight line, we get that the limit is 1/2, and my claim is confirmed, so the limit does not exist. So conclusion, limit does not exist. The limit does not exist. And therefore, we can't extend by continuity this function. So therefore, f cannot be extended by continuity. You can, of course, extend this function by discontinuity if you want to. So you might find discontinuous extensions of functions, but they are not interesting. You can just say that you pick f tilde, which is equal to, I don't know, 0 at 0, and then you get a discontinuous extension, but this is not really interesting. All right, so it's 12 o'clock. I guess for today is enough. I suggest you to do exercises on computations of limits. It's very important that you master these things. And you can just pick random exercises in the book, or just try with the one that I gave you, which is hard. Or you can try with the exercises in the sheet of paper number 1, or you can invent your own exercises. Yeah, so, but just do them. Okay, so I'll be here for 3 minutes. If I don't get any question, we will meet again virtually tomorrow. You're welcome. All right, so I don't see any question. I will stop broadcasting this first. Yeah, can you show the challenge one more? Yeah, I know, I just stopped I will just upload the file right now on the canvas, so you'll have it there in at most 1 hour. Bye bye.